part 2 of the periodic table slideshow. We've already talked about the history, and we discussed Mendeleev and how he organized his periodic table by increasing atomic mass. And the current table of today we see here, and it is organized by increasing atomic number. And we said that it has a lot of solids and a lot of metals. And I think you can see from the periodic table color coding that that's pretty obvious. So let's go a little further. Let's talk about the parts. The columns going down here, 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 and so on and so forth. Those are called groups. And there's 18 total. You can see that they are organized 1 to 18. There are other periodic tables where you have A and B subgroups, but the general idea these days is we just number them from left to right, 1 through 18. So there's 18 columns. No, these guys down here are not part of any group. We'll talk about those guys later. Periods. So these are the rows, and I usually tell my students that there's usually close to the number of periods in a school day. It might not be exactly 7 periods, but it's closer than 18 unless you're on some very weird school schedule. So that's how I tell my students to remember that periods go left and right, or that how you end a sentence is with a period typically, and periods go horizontally across a page. So the periods are going across. And yes, even this top one is a period. That's period 1. It only has 2 elements, hydrogen and helium. It looks like this should be 8 and this should be 9. But if you look closely, you realize that these are offset from the main periodic table. And let's see if we can take a look at that. You'll notice that we have 57. Now, of course, we haven't talked about what these are, but this is the atomic number 57. And then it goes up to 72. Well, really, if we should follow chronologically, 57, 58 jumps down here. And then here is actinium, 89, and we see it goes to 104. Well, it really should go 89 down to 90. So what's the point? Why do we take all these elements here and put them down in this part? Well, if they were put where they're supposed to, we would have to shift this entire section to the right, and then we would bring this up. And if we did that, it would pretty much be double the width. And that's pretty hard to do when you're trying to put a periodic table in a textbook. I mean, you could do it, but you couldn't read it because you'd have to make the font so small. So it's a convenient way to still have these elements represented, but not take up too much space. So we say that this is still part of period 6, and this is still part of period 7. So there are only 7 periods. Eventually, there could be an 8th, and it would start right there. But right now, that's not happening. Now the squares are called keys. Each one of these is a key. And in each key, there's a standard amount of information. And depending on what periodic table you're looking at, sometimes there's more than this. But usually a periodic table is going to have the name, the symbol, the atomic number, and the atomic mass. Those are the four things that you'll usually see automatically placed inside the key. Of course, if we go back and we look at periodic table, a little bit better. Better view. We see that this periodic table has just that. So for example, titanium, its symbol is Ti, its atomic number is 22, and its atomic mass is 47.867. So the decimal number is the atomic mass, and the whole number is the atomic number. There are some periodic tables that are overwhelming with information. You'll see numbers just all over the place here. And that just jumbles it up. But there are periodic tables that are like that. The density of the element, how many isotopes it has, what's its melting point, what's its boiling point, what is its ionization energy. There's all kinds of crazy stuff you can put in this little area. But obviously the more stuff you put in, the more confusing it gets. So I prefer, when I'm looking at just the basics, when you're learning the periodic table, to look at it in this method. You know, you have your name, your symbol, the atomic number, and atomic mass. And that's the way our class copies are set up. So let's take a closer look here. Oops. The symbol is going to be one or two letters. There's a few exceptions to that. There are some that have temporary symbols, and those symbols are going to change once the element gets officially accepted. It can take years for the scientific community to recognize a new element added to the periodic table. It's done by the IUCP. International Union of Pure and Applied Chemistry. These guys, oh, I shouldn't say guys, these scientists are the ones that will make decisions over if a name is accepted, and if they can go back and actually change names. That's happened before with some elements. So the International Union of Pure and Applied Chemistry, until they make the official decision, you do not have a name, you have a temporary name. So let's go back and look at our original slide. These down here, you have ununbium. Well, ununbium is a temporary name for element 112. And this book was copyrighted in 2008. Since that time, this element now has an official name, copernicium. I think it's CP, the symbol. And it took quite a long time for it to officially be accepted, because scientists from other labs want to prove or disprove that that element can be synthesized. We haven't mentioned it, but most of the elements down here, as you get farther down, are synthetic. You can see that there's a symbol for what elements are synthetic. And starting here with rutherfordium, you see all these are synthetic. So scientists from across the world would try and recreate this element, and if they do over a period of years and nothing weird happens, then it gets officially named. This one also was recently named in 2012, and this one here, I believe this is fluorovium and this is livermorium. Might be backwards, but this fluorovium and livermorium. So element 115 and 113, and I forget 117, but it does have a temporary name right now. Unoctium 118. These will eventually be named as well, but until they officially get named, they have these temporary names. And actually, the word is Latin for that number. So if you want to say 113 in Latin, you say untrium. You want to say 115, you say unpentium. You can kind of figure that out from the sound. Some of the symbols make sense, Be for beryllium, and then you have some that don't make any sense at all. You know, Hg for mercury. Well, mercury and the symbol mean the same thing, but this is based on its old name. Hydrarium, I believe is what it was called. And gold is Au. Well, it was aurum. And copper is Cu. And silver is Ag. There's a lot of examples of elements that have their old symbols but newer names. And you'll see that with a few elements. But there are some that make sense. Well, I'm going to say make sense, but they're easy to see why they're the symbols. And then these in the alkaline earth metals, certainly you can tell that. All right, the atomic number, this guy, tells you how many protons and electrons an element has. So if we were talking about magnesium, it has 12 protons. We typically will show protons with a little plus sign because they're positively charged. It has 12 electrons, and we show electron symbol with a little negative sign. The atomic mass, the average atomic mass, is usually the decimal number. We'll talk about the source of that number in future slideshows, but right now we'll just talk about it. You recognize it as the decimal number. That's the difference between the atomic number and the atomic mass. And it's an average atomic mass that we'll get into later. And then the mass number is the atomic mass rounded to the nearest whole. So the mass number of magnesium is 24. The atomic mass of magnesium is 24.305. The mass number of beryllium is 9. The atomic mass of beryllium is 9.012. And the mass number is very important because the mass number allows you to identify the neutrons. So if we were going to try and find the neutrons for magnesium, well, here's the formula. If the mass number is 24 and the proton numbers happen to be 12, then we would just subtract 24 minus 12 and the neutrons would equal 12. And you have a little n with a not symbol, and that simply means that it doesn't have any charge. Neutrons are neutral. The mass number for calcium is 40. The atomic number is 20. If I wanted to find the neutrons, I would subtract 40 minus 20, and calcium has 40 neutrons. The beryllium atomic mass is 9.012. The mass number is 9. The atomic number is 4. So beryllium has 5 neutrons. So don't think that the neutrons always match the electrons and protons. It just happens to be that way for some of the earlier elements. As you can see down here with these, they start to become rather different, well, pretty large change. All right, that's periodic table PowerPoint Part 2, and we'll continue with Part 3 soon.